Today, we're going to talk about continuous integration with release management. My name is Sachi Williamson, and I'm an ALM developer at Northwest Cadence. So first, picture this. Organizations have a need to manage the releases of their software, either to standard environments or to production. There are several release management solutions available, but until recently there has been no Microsoft offering. Now companies are asking about Microsoft Release Management for Visual Studio and want to better understand its capabilities. Questions that we'll be addressing today are questions such as: how does release management support deployment to multiple environments? How does it handle approvals? How easy is it to configure, and what type of infrastructure and setup is required? What we're going to do today is we're going to show you an end-to-end solution, starting with checking in code with continuous integration, so building automatically and then deploying it to release management across 4 standard environments: dev, QA, UAT, and production. So let's start with talking about fast feedback. Release management is all about fast feedback. What this means is driving software development forward, or modern application development forward, with more frequent release cadences, delivering value to stakeholders faster, and receiving feedback quickly to improve products and general understanding. So getting everyone on the same page, having stakeholders review more quickly so that you can make sure that you're on track with what they're expecting. So at the heart of all of this is feedback loops with fast feedback. What this means is rapid value delivery to stakeholders, by having those shortened feedback loops, having that tight loop to quickly release and then get feedback, whether that be every week, every 2 weeks, rather than once a year, because things can change by then. So leading into that, you don't need to schedule a release for 1 year from now or 6 months from now when you have something like release management, because you can release as often as you'd like or have a short turning radius without worrying about having things change. Something that release management is really good at, as well as other tools like this, is reducing that risk management, reducing maybe the market will change in a year and so your product will be obsolete, or maybe your stakeholders decide 6 months up down the road that's not what they're looking for, but they haven't told you until you give them the product that you're looking for, that you think they're looking for, and then they tell you that it's not correct. So it's just reducing that risk of being on a different page with stakeholders, or having something that breaks down the road 6 months or to a year, just by not having that fast feedback. So not needing to have long planning needed, and so you can release more often, maybe at the end of every sprint or iteration rather than every 10 iterations. So imagine having an environment for each developer. With release management, you can create as many environments as you need, whether that be for each developer or for each department, such as having one for dev, one for QA, one for UAT, etc. Because feedback loops aren't just about getting feedback from stakeholders, they're about understanding and reacting to any and all changes to the product, regardless of if you're a developer or you're QA or you're a stakeholder. Because just saying that it didn't break the build isn't good enough anymore. The end customers, the stakeholders, whoever they are, want products that work, not just something that built and was kind of half finished because planning didn't work out so well or requirements changed, anything like that. Just making sure that code compiles isn't good enough anymore. That's not high enough standard. So in today's rapid delivery world, it has to be, don't break the application or app, because your app needs to work in the end. That means that it needs to be deployable and deliver the value to your stakeholders that they expected across any environments that they need. And your customers really don't care in the end if your code compiles and it didn't work in a particular environment. So what we're going to start with is setting up standard environments, particularly in Windows Azure. This is really useful for when you want to create multiple environments. In our demonstration later on in release management, we use about three Azure Virtual Machines. So this is how you can set up standard environments, and there are a lot of benefits to this. So going into Chrome or whatever your favorite browser is, if you go into the portal of Windows Azure or Microsoft Azure, it will show you some sort of image like this. It allows you to create any types of items that you're looking for, whether they be websites, mobile services, cloud services, storage, HDInsight, but particularly we're going to look at virtual machines. So this allows you to create as many virtual machines as you need, depending on how many you need for maybe dev or QA. Something to note is that with Microsoft Azure, as an MSDN subscriber, if you have those MSDN subscriptions, you automatically get X number of credits for having Azure. If you have premium or above, you get $100, so that will last you for a good amount of time, and you'll get those $100 or whatever the amount is every month. So since you have those credits, you might as well use them, right? So I'm going to show you how to create a virtual machine from the gallery, and then I'll just also point you to where you can upload custom virtual machines. So there are three types of ways to create virtual machines, essentially. There's the quick create, which kind of just gives you a couple of fields to put in, and then it creates the virtual machine. There's also creating from a gallery, which gives you a bunch of images that Azure has already created, such as Windows Server, Linux, a couple of others with with software installed, such as SQL Server and Visual Studio, and then you can also upload your own. First, let's show you how to create one from the gallery. If you go down to the New button, kind of down in the lower left-hand side, click on New Virtual Machine. You can click on Quick Create, and it will give you just a few options and make it really simple for you, or you can go from the gallery. If we choose the gallery, it will allow you to choose an image. You can choose Windows Server, various different versions of Windows Server, some that have SharePoint installed, SQL Server, you also have Oracle, Java, Visual Studio, and Linux. So you can choose any of those that you'd like. You can also choose from images that you already created yourself, custom ones. I don't have any of those, so I can't show that. But if we go back to all, and let's say that we choose Windows Server 2012 R2. We're going to click Next. You can choose a version release date. We'll just choose the newest one. You can name the virtual machine whatever you'd like. We'll just call it Sachi Release Management Demo. Name it whatever. Choose the tier, basic or standard. And then you can also pick the size. Something to keep in mind is if you have something like $10 of credit left, you probably don't want to pick something that's 56 gigabytes of memory. But what we're going to do is we will choose something in between 768 and 56, probably 3.5 gigabytes memory. Create a username. And then when you're ready, click the Next button. You can create a new cloud service or choose from existing cloud services if you've already created some for other purposes. You also can choose the cloud service DNS name, as well as we're going to change the region to be West US. And then, again, very similar to cloud service, you can either use an automatically generated storage account or use one that already exists. You can also choose to use an availability set. We're not going to do that in this case. And then you can lastly pick additional endpoints that you're looking for, such as SSH, FTP, SMTP, however many you'd like. We don't need any, so we'll click the Next button. And then lastly, you can install agents if you want, or configuration extensions and security extensions. All of this is just kind of dependent on what you're needing to do with this. When you finish creating a virtual machine from the gallery, you can click on the check mark and complete. It will take a few minutes to provision it and spin up, but then other than that, you're good to go. The nice part about having this in Azure is that you don't need to do any server maintenance or worry about your on-premises server being down or anything, because it's all housed in a big data center somewhere across the US. So that's how you create a virtual machine from the gallery. Let's just take a quick look at creating your own custom ones. If you click on the Images button right next to Instances, you can create an image, and so name it whatever you want. description of it. One thing that you'll have to do before you go to this section to create an image is you'd actually have to upload a virtual hard drive URL, or excuse me, a virtual hard drive into the cloud service, and then from there you'd have to select from that virtual hard drive. So that's something that you'll probably have to Bing if you don't know how to do that already, and then you can choose between Windows and Linux. So again, just make sure that you have a virtual hard drive that's been uploaded to the cloud service, and then you'll specify the URL from there. You'll also have to run something called sysprep on the virtual machine, so that would be just making sure that everything is, good to go. So again, check out Bing for that. It has some really useful information on how to get started with that. So that's how you can create a virtual machine in Windows Azure custom one. One last thing that I want to show you is this button on the bottom called Capture. What that allows you to do is create a template off of a particular selected virtual machine. So in this case, I have Dev Windows 2012 selected, and now what I can do is I can capture the virtual machine and use it as a template. So if I want to duplicate it across multiple environments, so let's say I want Dev, QA, UAT, and Prod, if they're all up in Azure, if I want to duplicate that, then I can just use that template for all four and they'll be the same, which is pretty cool. And then lastly, again, make sure that you've run sysprep on the virtual machine. So that's how you create Azure virtual machines. They're very useful and convenient if you're not wanting to deal with server maintenance. And additionally, if you already have MSDN subscriptions, then you might as well use those credits for something, whether that be for those servers or experimenting, whatever it is. Again, as I said, MSDN subscriptions, if you've got MSDN subscriptions, you've already got that benefit of having Azure credits, so what are you waiting for to use it? You can also, again, I just showed you that you can set up VMs just in Azure with a few steps, and it's pretty easy to do it. There are lots of different templates for creating virtual machines, as we showed you with having Windows Server, Linux, anything in between. It's also very tightly integrated with Visual Studio 2013, so if you have that, then you'll be able to access different Azure things in client tools rather than having to do it in the command line. So it's very tightly integrated. So environments for the team that just work, really, that's what Azure is all about. Having, benefits of having a hosted dev test solution extend beyond the individual developer. So let's say that your team is creating software in iterations or sprints. It isn't really an iteration unless that app is deployed and tested, right? If you have 10 iterations and one release after the 10th, it's going to be really difficult for you to integrate feedback from maybe, let's say, the second or third iteration. Your team can't really get that feedback they need without those frequent deployments. So don't let those infrastructure constraints break your team's agility. With Windows Azure especially, you can provision test environments quickly and easily, keeping your team moving at the pace of today's business world requires. So here are the general concepts of release management that you need to know to understand release management. First, we have the release management server, which is essentially the heart and brains of the solution and consists of the database, the workflow controller, and a dispatcher that synchronizes activities with the target servers. You also have the client that comes in two flavors, which would be a Windows Presentation Foundation-based client that exposes all the functionalities of the application, and then you also have a web client designed for testers, user acceptance approvers, and managers. The deployer, next up, is a service that is installed on the target servers where the application components need to be deployed. It's really important to note that the release management server doesn't require access to this target servers at all, as all operations are based on a pull mechanism from the deployer. So I'll say that one more time. It's really important to note that the release management server doesn't require access to the target servers, as all operations are based on a pull mechanism from the deployer. And then lastly, we have deployer tools. So the release management solution provides various installation tools that assist different deployment scenarios, such as uninstalling and installing components, deploying reports to Microsoft SQL reporting services, moving files to specific locations, and many others. So we've got 4 key components of release management. So here's kind of an overview in a visual way of what release management would look like. So what you'd have on the far left is you would have the build template that is actually the release management build template. It would be called release something or other in Visual Studio. And then what you would do is when you kick off a build, it would put it to a drop location, and then it would move it over to the release management server as long as it's the release management build template. And then what would happen is the dev and QA machines would pull from that release management server rather than the opposite way around. So they would pull it. And then you'd interact with the release management server by either the release management web client or the console client. Either way does the same thing that you're looking for. So here's our demo. This is what our demo kind of looks like. We have Visual Studio. Our machine 1 just has the main release management server on it. Machine 2 has the console and the web client on it. And then we have a dev environment and a QA environment, both of which are hosted on Windows Azure. And then we also have internal servers that have UAT and production. So what we're going to do is we are going to kick off a build in Visual Studio. Once that build is complete, it's going to push it on over to the release management server, or machine 1. And then what's going to happen is, using machine 2, we're going to control whether dev environment approves that push over to it, or the pull, excuse me. And so the dev environment will pull from the release management server and pull all that information and just deploy it up. And then what will happen is we'll go through that, and then QA will do the same thing, and then we'll do, lastly, finish off with UAT and production. So they're all going to be pulling from this release management server. So here's the demo that you've been waiting for, using release management. All right, so if we go into the remote desktop, we have a remote machine that we're going to be connecting to. Let me first show you an overview of all of the windows that we have open. We have a project called Tailspin Toys. What we're going to do is we're going to edit this About page. We're going to change something on here, and right now this is the Azure VM that we have called Dev, Northwest Cadence. So this is Azure Dev, and then we've also got the QA, which is also Azure machine, and then we've got UAT and production. So UAT and production are the internal servers, and then we have Dev and QA, which are the Azure machines. And then lastly, we have the Release Explorer, and then we've got the Release Client on machine 2. And so that's the one that I'm on. So the first thing that we're going to do is we are going to make a change in this About page so that we can show you what it looks like deploying it to all of those environments. So I think what I'm going to do is I'm going to change "We are the coolest" to "We are the best team ever, and here's why." Excellent. Now that we've made that change, before I go into checking it in, because it's going to kick off that build automatically, let me show you what the build template looks like. If we go into Builds, let's click on RM Main Tailspin Toys. That's our release management build template. So build definition name, pretty simple. If you go to the trigger, you'll see that it's continuous integration, so it builds each check-in. Every time you check in, it will build it, and then it will actually push it off to the release management server. So source settings and build defaults, pretty standard. If we go into the process, you'll notice that the build process template is release default template. And so this is the only template that will push it off to release management. A couple of main things to note here, other than everything else looking the same is that we have release build. So what this does is if it's set to true, it'll indicate that you want that build to be released using the release management server. So if you set it to false, then it won't push it out to release management. If you set it to true, it'll be released using release management. The other one is specifying the target stage for the release. So you'll want to use this if you want to target a specific release stage. But we're going to leave that blank so that the release can go through all of those stages defined in our release path, which I will get to showing you about. So again, main kind of components of the build process template are the release build set to true and then the release target stages. So that's our release management build definition, excuse me. So if we go into pending changes, we made a change here, we saved it, we'll show in as included changes. We're just going to say Sachi made change to about for demo. Then once we check that in, we'll say that it's successfully checked in, and then it will actually just start building it automatically. And it will take a few minutes to build. Now that our build has completed, what's going to happen is it's going to push it out to Release Management. So the first thing that we're going to do is go into Release Explorer. We will refresh the page. Alright, and now it will show waiting for approval build triggered at 1:40, which is approximately 3 minutes ago, which should be correct, to the dev machine. The dev stage, excuse me. And so what you can do is if you click on that little dev box, we'll open up the stages, and automatically the dev stages accepted, installed, validated, and to approve are set to automatic. This can be configurable, so you can set it that you have to manually approve each step, or, you know, again, automatically. So you can configure that, which I'll show you in a bit. And that's pretty much it. So the first thing that we're going to do is we're going to just click on this waiting for approval step here, and then we'll click the approve button. Actually, before we do that, we're going to make sure that it's been deployed. So if we refresh this page, it looks like it's changed it to "We are the best team ever," and here's why. Again, the reason that it deployed automatically to this dev environment is because we set it to have automated approvals or automatic approvals. You can configure this if you like, and you can set it up so that various entities have to be approved for each unique stage, however you'd like to set it, but this was automatic for dev. So now that that works, if we click on here and click on approve, then we'll just say deployment to dev is correct. Once we click the approve button, then that indicates that the deployment was successful. And so what will happen is it will now push it over to QA. So if we go to previously approved, if we click on the QA, now what happened was it was automatically accepted into QA, but we're waiting for the other 3 stages. While we're waiting for QA to go and be deployed, let's just check out Release Management itself. So in the Release Management client, this is the WPF version, we have several different tabs. We've got releases, which show traffic overview, so we'll show traffic right now, as well as notifications. It will show releases, and we'll come back to this, and then my approval requests. You can also configure your apps so that different components are deployed, or you can have both of them deployed. You can also specify the release template that you'd like. If you click on the Configure Paths tab and open up the release paths, called Tailspin Toys Release Path, this will show you all of the stages that we have going to different environments. So we have the dev stage, QA, UAT, and prod. These all are mapped to different environments. So we've got the dev Azure, QA Azure, UAT, production environment. So they're all mapped to various environments. You can set whether acceptance steps are automated or manual. If you uncheck the automated checkbox, then it will be manually. So you will manually need to approve it. So you can notice here that we have both of those are automated, and then we have one approver, and you can specify who the approvers, owners, and validators are. And again, you can just customize this as much as you want. And then you'll notice in our production stage, none of these steps are automated. So that means we will need to manually approve each step. And again, you can configure this to as much as you'd like. You can add stages, remove some, etc. If we go back to releases, we'll notice that we have, let's go to the releases tab here. You'll notice that we have right now this build triggered release, which was the newest one that we just did at 1:40. If we double click on it, you'll notice that there are a few different tabs, such as View in a Tab, Approval Requests. So we have one approval request waiting for us for QA. If we click on the Properties tab, more importantly, you can actually see which build that you have that's associated with this release. So we have the main Tailspin Toys 2014 0529.2. So we have that build, that's the name of the build that's associated with this release. So many customers have difficulty finding that tab, but if you click on the releases and then properties for that specific release, then you'll be able to find which build is associated with that release. So if we go back to my approval requests, let's check out QA right now. What we're going to do actually first, before we accept this approval, is we're going to check out the QA environment. So if we refresh the page, it should be edited. And it looks like it has. And so there's our new text that we changed that's now both in Dev and QA. So if we go into the Release Client, again, this is the same way that you could do it in the Release Explorer in Internet Explorer. If we go to My Approval Requests, we'll have a big list of various previous requests. If we double click on the top one, that was for the build triggered at 140, which was the one that we just did. If we double click on that, again, check out all of the information for it. Make sure that that's the correct one you're looking for. Single click on it, and then you can choose to approve or reject the approval request. What this one is it's checking to make sure that QA has been successfully deployed, which it has. So we're going to say confirmed deployment to QA in the comments. We're going to click OK, and now that will go away. And so we can do it in here, but I'll show you it again in Release Explorer. If we go back to Release Explorer, we're going to click on the To Approve link. The reason that we have another approval waiting for us is because this is to simulate having QA run a bunch of tests. So the first one was for deployment to QA, and so now what the QA would probably do is that they would run through tests, and assuming that they were successful, then we would be able to approve the next one. So we have confirmed deployment to QA, and then what's waiting is pushing it over to the UAT. Alright, so if we click on Approve, we're going to say tests passed, ready for UAT. So again, the test passed from QA, and now we're going to move it to the UAT environment. If we click Approve, now what's going to happen is the release is going to move to UAT, which is an internal server. And so there are going to be two phases for the deployment of UAT, validation and approval to deploy to the next environment. So we're going to say that confirmed successful deployment to UAT, and then the other one would be UAT tests passed, assuming that the user acceptance tests were run and they were successful. And this may take a few minutes to load up in the UAT server. And there we go. Once we refresh the page a few times, it will show that our change has been deployed to the UAT server just from that approval. So there's our change. We're the best team ever, and here's why. So if we go back, let's just use the Release Explorer. If we go back to the Release Explorer, let's refresh the page. And now what's happening is it's waiting for validation for the UAT stage. So it was accepted automatically and installed automatically, and what it's waiting for is to validate that the deployment was successful. So if we click on that, it's highlighted. Click on the approve, we'll say confirmed successful deployment to UAT. If we click on the approve button, then again it will have that automatic approval waiting from just like the QA one. So it's waiting for a bunch of UAT tests. Let's say that we ran all of our UAT tests and they were great. And so what happened, again, confirmed successful deployment. And so now what's happening is it's waiting for, once those tests have passed, pushing it over to production. Now that we've highlighted that, again, highlight, click on the approve button. It may take a second to load. Then what we'll do is we'll say UAT tests passed, ready for production. All right, and now it's pushed off to the production server. Something to note, if you remember our release path before, none of our approvals were automatic for production. So what you need to do now is, let's say that everything passed, we do want to push it into production. If you click on the production stage, it should show that it's waiting for the project administrators to approve accepting it into production. So it hasn't actually pushed it off to production yet. What only happened was that the UAT test passed and then it said it was ready. So again, if we click the approved link, we'll say, do you want to continue? Yes. Accepted into production. Something cool to note with this is that you can actually defer that deployment. You can either have it deploy right now to production, or you can have it defer to a specific date at a specific time. But we're just going to have it move right into production right now. So we're going to click approve, and then it's going to go into the production environment. If we go back to previously approved, and if we click on that production button, we'll say that it was accepted into production, which it was. And it's going to take a few minutes to install on the production server. And there we go. Looks like our change has been successfully deployed into the production environment. And this is again an internal server. So now that our change has been successfully deployed, what we'll do is we're going to actually go into the release management client, not the release explorer, just to show you a different view of this. Again, if we go into my approval requests, if the particular release is open, we can close it. And that will also be, if we refresh the page, it'll have it updated, and it will say project administrators are the owners, the release. Again, that was the release that we had at 1:40 today into the stage and environment prod. And it's validating, it's waiting for us to validate the deployment, excuse me. So if we double click on that, or we can just do it from that page. We're just going to click on this and click on approve. We're going to say confirmed successful installation to production. And then we'll click OK. And that will go away. Perfect. At this point, what you'd want to do is you'll have some final production tests, and those would proceed. We'll just presume that all went well with that, just like we did with UAT and QA. And so then what we're going to do is we're just going to click on, again, that link, and we're going to say approve. And now, since it's ready to go live, we'll say production ready for release. And then you click OK. And we shouldn't have any more approval requests waiting for us. And then it will say that it was released. And the really cool part about having this is that you can view a log, so it will show you all of these steps with details if you'd like for some of them, for the number of attempts and which stages your release went through. And it went through all of the releases. And so if we go back into the Release Explorer and previously approved, it will show that all of our comments, and it will show that it was accepted, installed, validated, and then production ready for release. And so it was released there. So that's how you go through release management to manage your deployments to various environments, whether they be in Azure or if they're internal servers. You can just manage all of those in one place and control approvals, as well as configure which environments it goes to in which order, and how they interact with the release management server. So let's go back to our deck, finish this up. So as a summary, Azure Release Management in your team, it's very scalable with Azure, from having a single box to multi-server environments. We only used 2 virtual machines for dev and QA, but you can have as many as you'd like with Azure, and it scales to whatever level that you need. You could administer the environment just in Azure, and it's very simple, only takes a couple of minutes, and they're all located in the same place and fully functional. The nice part, again, is that, you know, much less risk of having Azure go down, the Azure data center, from, you know, your small on-premises server that you're always biting your nails to make sure that it doesn't break. You also get scripted deployments, PowerShell, Active Directory, all of that and more just with Azure. It's tightly integrated with all the Microsoft platforms such as Visual Studio and TFS to SharePoint and Office 365. So it works with all of the products that you're already using. Just gives you that freedom to have you know, your virtual machines in the cloud, which is great. So, operations out of sync. So, what operations out of sync is referring to is the development and testing cycle time. Most of the IT shops that you'll see aren't as fast or as mature enough as they want to be to keep up with that cycle time of development and testing. This causes constraints in operations to try and keep up with everyone and be in sync with development. So, you know, if development has a really fast loop and ops is good amount behind it, then they're going to be out of sync, and it's going to be very difficult to release and coordinate dev and operations. This also will cause some frustration and resistance to having that change, and keeping those innovative features from the customers and placing strain on the delivery cycle when they're out of sync that way. So what's required? Here are a few ideas. Adding ops to development teams, having a person from the operations team be on the Scrum team, so they can provide their insight. You know, what is actually feasible for this iteration? What's our release timeline? Anything like that. You also need ops willingness to changes. That's going to be, you know, it depends on how ops was working before, but this really needs the ops person needs to be open to this next change and not hold that line. One of the most important things that you need is trust, because it will take a lot of trust to have a smooth running continuous delivery process. Trust will only build with success and time for having a lot of releases. So, trying to have maybe a release every month, and then slowly moving towards having them every 2 weeks. So having all of those successful releases, building that trust, and then having that consistency is really going to help you out with trying to achieve continuous delivery. And then lastly, automation. As you can tell through release management with a couple of the automated steps of approval and validation, other things like that, reducing those errors in manual process can help build on all of those above points. So including automation in your pipeline. So the value of having all of this. Business wants to have new features to the customer base in less time, right? This gives the business leader the ability to shape the market trends and not just react to them. What you also will get is customer feedback to the teams on what they want and the priorities faster. And then lastly, teams are more focused on not just guessing or not knowing what is next, but actually being able to communicate with the stakeholders and understanding what they want and what they're not really liking with your product. So just having this faster feedback be possible is a huge step towards having faster deployments and better quality products. So benefits, one source says that less than 50% of the business leaders today would say that they can deliver new innovative software in 12 months or less. Let's try to change that. Let's try to have faster cycle time so we can get faster feedback, so bugs are easier to find and resolved, as well as just have everyone be happy, and to reduce that technical debt. So technical debt is reduces everyone being on board and working on small issues rather than large and ugly ones that get ignored or get placed till the end of the release cycle, and then everyone's, everything's disorganized and in disarray. So having that faster cycle time, faster feedback, and reducing that technical debt with that extra time, this really helps to, give your business or product or application that longevity that it needs. So who needs to be involved? Who do you think needs to be involved? I'll give you a hint. It's everyone. If you guessed everyone, you were correct. Senior managers all the way down to development, tests, release management, and operations. Everyone needs to be involved in this game. If the company isn't able to keep everyone involved and be trying to focus towards this continuous delivery, then it'll be really difficult for them to keep up and keep up that innovation by if they're releasing a year or 2 years down the road, they may be completely behind everyone else. So, if you don't have this fast feedback getting started, having those discussions about continuous delivery, it's a good time to start doing that, because other smaller products or companies may be already thinking of new ideas. So, levels of maturity, I'm going to go through these pretty quickly, but first, for the levels of maturity, we have ad hoc releases. What this would be is teams rely mainly on manual testing after development is complete to find defects. System integration is also kind of painful and happens after development on a module is completed. Provisioning production-like integrated testing environments is expensive and manual, and deployment process is manual. Developers, testers, operations, and management have goals that bring them into conflict, and change management is ad hoc or heavyweight and often circumvented or ignored. So once you get past that level, hopefully you get past that level, there's an adaptive delivery process, time box releases. Change management controls are implemented, including a process to detect unauthorized changes with consequences defined. Business participates fully and regularly in development activities and decisions related to delivery. Production-like testing environments are available for projects early on. There's some scripting to reliably and repeatedly configure environments and build packages from version control. And then lastly, working software is at the end of each iteration. And then we've got the third level for regular releases with quality. So teams build quality into the release process. Teams practice trunk-based development with continuous integration of all changes. Automated tests that target critical defects are detected and prevented fast and automatically. No work is considered done until it has passed automated unit and acceptance tests associated with it. And then the fourth level is delivery teams prioritizing keeping code trunks deployable over doing new work. So releasing on demand. Cross-functional end-to-end product-centric teams manage products throughout the lifecycle, and comprehensive automated test suites are created through test-driven development, or however else you want to do it, automated test-driven development, and maintained by developers and testers working together. Teams monitor and manage work in process and deliver work in small batches. So all of these are kind of moving up on the scale in terms of being more towards continuous delivery. And so lastly, exploratory driven delivery. Teams are focusing on optimizing the cycle time to learn from customers. Systems are architected with continuous deployment in mind, supporting patterns such as dark launching to decouple deployment from releases. And all new requirements describe how the value of the feature will be measured. So the goal of this would be for you to gain as much maturity as you can, have the highest level of maturity that you think is possible for your company, and to challenge yourself to even strive to be better than that. Because the most successful teams will be the ones that can change quickly and adapt to that change, rather than, having very slow and difficult and painful releases every year. So here's an example of a continuous delivery model that we have. The delivery flow model, this is kind of an overview of one that has a number of feedback loops. What you do is the delivery team from the far left checks in code with version control, which triggers a build, right? So maybe this is continuous integration build. Then what's going to happen is once you get that continuous integration build, it builds, let's say the build fails for the top one in red, then it provides feedback back to the delivery team. Then when the delivery team fixes those bugs, checks it into version control, again, automatically triggers with continuous integration. Then what will happen is once those unit tests are successful and build successful, it will go into automated acceptance tests, and then if automated acceptance tests fail, goes back to feedback to the delivery team. And then you just keep going through this until everything passes all the way up to release, and then you get feedback from that release. So it's really kind of just going back and forth, but having as much feedback as you can and as often as you can. And then we've also got continuous delivery flow. This is really similar to what we were showing you earlier in the release management demo. We've got a bunch of service developers and UI developers. They all check in to source control and build servers, and then those go into different environments, such as development and UI integration. Those go into QA environments, and then staging, and then production. So it's just kind of having that continuous flow going throughout all the environments and that are testing those environments to have successful deployments. And then we've got the 3 golden rules of continuous delivery. So the first one is don't break your customer. No one likes customer dissatisfaction and trust. Breaking an existing feature, breaking the customer trust, intruding business flow, all of these are can be detrimental to your product success if you lose customer loyalty or trust. Just like that machine. And then we also have don't break the code, builds, tests, or production. Most importantly, production. Having big bang releases, and breaking production, but by not engaging them early on, and having the team wait while they're fixing a bug or issue. All of these are very costly problems that you can get. So having those stable and trusted delivery system, such as maybe going through each of those environments automatically, having those approval processes, those are one step closer to allowing you to have successful deployments in all of your environments. And then lastly, you have don't break the delivery flow. So having those reliable models to quickly react to changes or feedback, whatever it is, with less risk. So having that solid delivery model, having easy releases and not having any surprises. So reducing that risk and having that flow continuously. So those are the 3 golden rules that you should be sure to try and stay on track with. And then it will be happy. So the tools that we use today, again, to develop were Visual Studio. We use Team Foundation Server with the builds. We also could use PowerShell if we like. You can deploy with release management with NuGet packages as well, and then you can host them in Azure, either if you're an MSDN subscriber or if you're just an organization. If you have any questions, feel free to contact me or contact anyone at Northwest Cadence. Thank you so much for your attention.